Swayam Prabha. Digital India. Educated India.
In this unit, we'll look at control sources. Now, so far we have discussed elements like the voltage and current source and basic elements like resistor, capacitor and inductor. Okay. These control sources are also elements which we will see in many circuits. Okay. So, unlike a resistor, they do not correspond to some physical entity, but they are most often used as models for abstracting the behavior of more complicated circuits. Okay. So, they are very useful in circuit analysis and circuit design. For instance, an amplifier which is used quite commonly can be thought of as a control source. It is controlled by the speaker's voice or the output from the microphone, and it controls the output that drives the speaker. Okay. If you recall, a resistor is an element which enforces a particular relationship between the voltage between two terminals and the current going through those terminals. Okay, and that relationship is given by Ohm's law. That's a linear resistor. Now, when I said control sources, the control sources in general can be linear or non-linear, but here we'll consider only linear control sources. Now, control sources also enforce a similar relationship, but between quantities present at different pairs of terminals. Okay. Now, depending on which quantity is controlling and which quantity is controlled, we can have four different kinds of control sources. A voltage controlled voltage source, where a voltage between a certain pair of terminals controls voltage between another pair of terminals. And similarly, we can have a voltage controlled current source, where a voltage between a pair of terminals controls a current flowing between another pair of terminals. And similarly, we can have a current controlled voltage source, where a current flowing in a certain branch, usually assumed to be a short circuit, controls the voltage between a pair of terminals. And finally, a current controlled current source, where a current flowing through a certain branch, again usually assumed to be a short circuit, controls the current between a certain pair of terminals. We will take these control sources one by one and see how they behave. Okay. First, we will take the voltage controlled voltage source. Okay. This is denoted by this particular symbol. Now, independent voltage and current sources are denoted by a circular symbol. To distinguish the control sources from them, a diamond symbol is used. Okay. So, what this means is that these are the controlling nodes, and let us say the voltage between these two is Vx. This is the controlling side, and this is the controlled side, and the voltage between these two is given by some k times Vx. Okay. So, this k is a property of the voltage controlled voltage source. So, if I label these nodes N1, N2, N3 and N4, what this says is voltage difference between N3 and N4 equals K times the voltage difference between N1 and N2. Okay. So that's the meaning of the symbol, right? Now, first of all, why is this linear? So let's say Vx1 is the controlling voltage. This results in a control voltage which is K times Vx1, and if Vx2 is the controlling voltage, it results in a control voltage K times Vx2. Now, let's say the controlling voltage is alpha times Vx1 plus beta times Vx2. Obviously, this results in a controlled voltage which is K times alpha Vx1 plus beta Vx2, which obviously can be written as alpha times kVx1, which you see is the voltage in the first case, plus beta times kVx2, which you see is the voltage in the second case. Okay. The linear combination of the cause gives you the same linear combination of the result. So this is a linear element. Okay. And this must be pretty obvious from the relationship itself, because K times Vx is a linear function of Vx. Okay. Now, as far as this course is concerned, it's about circuit analysis. So some circuits will have these control sources, and you have to analyze the circuits with them in place. So you apply these element relationships. The one for the voltage control voltage source I have already given, and you will be able to analyze the circuit. Okay. Now, what does this do? For instance, if we have a voltage control voltage source, and between these, if I have, let's say, 1 volt, okay, and let's say for this voltage control voltage source K is 5, then between these two I'll have 5 volts. Similarly, if I apply an input, you can think of this side as the input and this as the output. Okay. If I have, let's say, 20 millivolt sine omega t applied to this side, on this side I'll get 5 times that, which is 100 millivolts sine omega t. Okay. So a voltage control voltage source is a sort of an amplifier. In fact, it will be used as a model for an amplifier. Okay. Now, one point I want to emphasize about this control source as well as the others is that they are unilateral. That is, you take a resistor, it has this relationship V equals IR, which can be interpreted both as applying a voltage V, which results in a current V by R, or applying a current I, which results in a voltage I times R across the resistor. Okay. So both ways are possible, but for a controlled source, that's not the case. You can apply 1 volt on this side and get 5 volts on that side. So in general, you apply Vx on this side and get K times Vx on the other side. Okay. This is the control source. But the other way around, you cannot apply a voltage to this side. So let's say Vy, the control volt source still is assumed to follow the same relationship, Vx and K times Vx. Okay, you cannot apply a voltage to the right side and get Vx equals Vy by k on this side. Okay, so this is simply meaningless. Now this is a voltage source. You cannot apply another voltage source across it. Okay, we know that parallel connection of voltage sources is not valid. Okay, so in a control source, the control flows only in one direction, from the controlling side to the control side. It's called a unilateral element. Okay, you cannot apply an input to the control side and expect some corresponding output from the controlling side. Okay, so this kind of thing is just not possible.